The United Nations Sustainable Development Goals, or SDGs, are a series of goals aimed at identifying and improving a range of social, economic, and environmental issues around the world. The 17 goals and 169 targets of the SDGs expand on this history, tackling problems such as preserving the biosphere and marine pollution. Goal 14, Life Below Water, specifically focuses on reducing harm to the world's seas. It has 10 key targets to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. The goal aims to safeguard the ocean against pollution, overfishing, ocean warming, and acidification, to name a few. The first target of Life Below Water is this: by 2025, prevent and significantly reduce marine pollution of all kinds, in particular from land-based activities, including marine debris and nutrient pollution. 14.1 only has two indicators to be monitored globally: levels of coastal eutrophication and levels of plastic debris in the ocean. Eutrophication occurs when an environment becomes enriched with nutrients, leading to algae growth and subsequent habitat death for native plants and animals. It is a naturally occurring process, but human activity has fast-tracked this century-long process into a near-constant occurrence. The SDGs aim to combat this by putting policies and laws in place. Similarly, the SDGs are working to fight the rising levels of plastic debris in the ocean, on the seafloor, and in marine wildlife. Both indicators are monitored all around the world and reported back to the United Nations annually. Unfortunately, the efforts taken to reduce eutrophication and debris have not been extremely effective. In 2023, the UN SDG Progress Report showed that eutrophication levels have not decreased, and marine pollution is still a major problem to our seas.
The term molecular biology refers to biological processes that occur at the molecular level, such as DNA, RNA, and how they interact with each other. Marine pollution in all of its forms has the potential to cause harm to marine organisms and marine ecosystems as a whole. In various scientific studies, it was found that marine pollutants such as plastics, microplastics, and heavy metals can cause irreversible damage to DNA of various marine organisms. This genetic damage has the potential to alter gene expression and cause harmful mutations in aquatic life, and even inhibit an organism's ability to reproduce. Over long periods of time, this could lead to a decline in population of marine organisms. An environmental movement called Save the Turtles became popular on social media at the start of the decade. This statement promoted the use of paper or reusable items such as containers or paper straws to cut down on pollution that eventually reaches our waterways. What if we told you that researchers have found an approach to creating a kind of plastic that does not become soggy when used and also doesn't linger in marine habitats for thousands of years? The environmental campaign inspired organisations such as NatureWorks and universities across the globe to use innovative microbiological-based technology to produce plastic composed of biodegradable components. This involves the usage of microbes, such as algae, within the product that can break down the material in as little as 7 months by essentially munching through it and converting the material to CO2 and H2O. Multiple phases of plastic deterioration must be completed by the algae-based plastic before it can be deemed an environmentally friendly micro-biodegradable plastic, also known as a BMP. This involves the following: Step 1, biodeterioration. Step 2, biofragmentation. Step 3, assimilation. And Step 4, mineralization. This ensures that the future is remaining green for generations to come. Researchers at the University of California, San Diego, are currently in the works of using algae-based BMPs to create conventional plastic items and equipment as we know it, such as phone cases, shoes, and straws, in order to reduce marine pollution. In a study conducted in 2023, the scientists discovered that after 200 days of their BMP being submerged in a marine environment, 97% of the algae-based microplastic had been biodegraded. Plastic pollution poses a major threat to marine life and ecosystems. By 2050, plastic in the ocean could outweigh fish. This pollution damages marine habits, contaminates seafood, and has serious human health risks. Additionally, it worsens climate change by harming ecosystems that naturally absorb carbon, like seagrass and wetlands. Key research areas for the future include how microplastics affect marine life and humans, the long-term impact of chemical pollutants like PCBs and DDT, and developing better technologies for pollution cleanup and effective global policies. Addressing marine pollution requires urgent global action. Reducing plastic waste, strengthening environmental regulations, and advancing pollution mitigation technologies are essential to safeguard ocean health and overall human well-being.